Here we have the first of our exponent rules, and these are going to come in really handy whenever we start working with larger and larger items. Okay, let's look at this first one. The product rule says if m and n are positive integers and a is a real number, then a to the m times a to the n equals a to the m plus n. So according to this rule, if you are multiplying the bases that are the same thing, then all we have to do is add the exponents. So let's put this into some practical use and see how it really works. Let's do a kind of a smaller example. Let's say we had x squared times x cubed. X squared literally means x times x, and x cubed literally means x times x times x. And then remember, we are multiplying these two things. So what we're really doing is multiplying x to itself 5 times. So this would become x to the 5th. Now if we'd used our rule, we would have gotten the same thing. Multiplying the same base, you would add the exponents. So if we multiplied the same base, we would add the exponents. So 2 plus 3 would give us x to the 5th. So same thing either way. Now, if you're doing something like this, not so bad. When you start working with larger and larger items, though, you don't want to have to write everything out. Like I don't want to write out x to the 10th, x times x times x, all of those x's. But I'm going to do something a kind of a long way here on this problem so that we can see what's happening, and then on the next one we'll take a shortcut. This literally means x to the 9th times y for our first parenthesis. And then our second parenthesis is x to the 10th times y to the 5th. And we are multiplying these two things. Well, if you'll remember about multiplication, it is both commutative and associative, meaning you can do it in any order that you want to. So according to that property, I should be able to rearrange this multiplication and say, let's multiply our x's together first, and then our y's together. Now by doing that, we can follow our rules of exponents. X to the 9th times x to the 10th, we are multiplying the same base, so we would add the exponent. So this would be x to the 19th power. And over here, y times y to the 5th, we're multiplying the same base, so that would be y to the 1 plus 5, which is 6. So our answer would be x to the 19th, y to the 6th power. Now we're not going to have to write all that out every time and use the commutative property and associative properties to move things around. Let's look at this problem. Once you realize that you can multiply in any order that you want to, we can multiply like items. So here we have a 4 times a negative 6. Those are both just numbers that we can multiply. So that would be a negative 24. And then we've got these z's that we can multiply together. We're multiplying like bases, so that tells us that we just add the exponents. So 10 plus 7 would be 17, plus 3 would be 20. So we would have negative 24 z to the 20th power.